That was regarding my initial 50 contacts or so on LEO satellites. By the time I had improved a little bit on my homebrewing skills, I tried to homebrew both VHF Yagi and UHF Yagi as advised by my Elmers on the LEO satellite group. But if you want to work with dual Yagi on a fixed base station, other than the antenna rotator, you need something known as a diplexer. Diplexer combines the signals of two antennas and gives it to the radio with a single feed line. But I did not have a diplexer. Most of the diplexers are low power and can handle only the output of a handheld radio. It cannot handle the output of a base station. I was on the lookout for one, but I did not get it. So instead of my fixed omnidirectional vertical antenna, if I had a dual band antenna, that would have been better even with a vertical antenna. Some of my friends are having good results, especially those who are living on high-rise apartments. They are having good results with vertical dual band antennas on their terrace. But I am not lucky enough for that. I didn't have that also. So I tried homebrewing VHF and UHF Yagi antennas with gamma match for tuning. But somehow it did not work out. All the Yagi antennas which I homebrewed had high SWR, and when you use two Yagis, you need a crossbar on which to mount the antennas. Then you need a mechanism to rotate it both in azimuth as well as elevation, which I did not have. And due to poor technical skills, I could not make one also. So my projects of homebrewing VHF and UHF antennas, Yagi antennas, to receive satellites and transmit on them did not work out. Finally, somebody told me that there is a very simple directional antenna which is known as Moxon Yagi. In Moxon Yagi, there are just two elements for VHF in the shape of a Moxon rectangle. That is, one is the director, the other is the driven element. The driven element is fed directly with your coaxial cable. There is no matching circuit, there is no tuning for that. It's a very simple antenna to make. And there are 5 UHF elements which are on the same boom. So you don't have to have two antennas, two radios, or any complexities. You just need a single boom on which at the one end you have two Moxon elements of the Moxon rectangle for VHF. In Moxon rectangle, as the elements are folded partly, the width of the antenna is also lesser. So it becomes very handy even if you want to operate it outside. And in your terrace also, it saves space, because I have only a very limited terrace space, a small balcony. The rest of it is sloping roof. So I have to have my HF antennas on that balcony as well as VHF antenna. So I can't have too many huge antennas on there. So this Moxon Yagi comes in very handy, and that can be rotated manually also. And the interesting part is that the UHF elements of the Moxon Yagi are passively coupled. That is, you do not have any physical connection between your coaxial cable and the UHF elements. They are just there. The VHF radiator element acts for both UHF and VHF, and the other UHF elements, 5 elements, help in directing the signals. That is how the Moxon Yagi works. Somehow I could get it with a reasonable SWR, just below 2, I would say. It was not 1:1, because of my excellent home brewing skills. Still, I am able to work it with medium power from my base station. Now, I have already told you that I do not have an antenna rotator, and I have mounted this antenna, that is the Moxon Yagi, on an about 8-foot long telescopic pole. Actually, the telescopic pole was bought for painting at home to lengthen the pole so that you can paint the upper part of the walls. It was a painting adapter for the rolling paintbrush, and I took it and put it on my balcony. It's if you lengthen it fully, it will be about 8 feet or a little more than that, maybe. So it is kept on my balcony, and the antenna is mounted on it. That's a very, very limited so-called satellite setup which I have. A Moxon Yagi, that is which one I am using now, because I am not using the CP22E antenna anymore. When the lightning season came, I reduced the length of the mounting pipe. That is, instead of the 6 meter GI pipe, I have changed it to a just 3 meter CPVC pipe. That is a non-conducting mass for my CP22 antenna, and the top of the antenna will not be above my roof. That is, first floor roof, which is a sloping roof, will be taller than the top of the antenna. So I have no hopes of working anything but the local repeater with my CP22E antenna, and I have to rely solely on my Moxon Yagi for working satellites. So I'll tell you what I do. I look at the satellite passes on either N2YO website, which gives the direction of pass in a graph on a map. That is the N2YO website. And then I look at the Argentinian AMSAT website, which gives the live Doppler and live direction for me. But direction I do not use, azimuth I do not use, as my antenna is fixed. Before the pass, I go outside onto the terrace and point the antenna in the direction of maximum elevation azimuth. Suppose the maximum elevation is 35 degrees and the azimuth is say 270 degrees to the to the west. I point my antenna directly that way, to the direction of maximum azimuth of the azimuth of the maximum elevation. That is where I point the antenna, and it is having only a fixed elevation, maybe about 15 or 20 degrees fixed elevation is there for the antenna, and that is nothing measured. I presume that it is around 15 to 20 degrees elevation for my antenna. Due to the excellent mechanical skills which I have, that also is not stable. It might change when you rotate the antenna, and I have not used any clamps for keeping the antenna steady, so it might also turn if there is a high wind. But most of the time there is no high wind, so for 10 minutes, if there is no wind, the antenna will remain wherever I have kept. So by keeping the antenna in the direction of maximum elevation, I am able to work about 4 minutes of each pass. That is, when the satellite comes on the horizon, I will not hear anything. When it starts rising, I'll start hearing some stations, and when it starts setting, then also I'll hear some stations, but towards both ends I will not hear anything. I do not have an antenna preamplifier, and sensitivity of the radio is not that great also, and antenna sensitivity is also not that great. Still, I am able to work about 4 minutes of each passes. If I am lucky, I will be able to work 3 or 4 stations during that period. If I am not lucky, I may not work anything or just 1 station. But I am happy with this limited setup because I don't have much trouble of going outside, and it is comfortable to operate from within my shack. This is the very limited setup of LEO satellite operations which I have.